It is now time for the TC39 panel. So you'll see some familiar faces. We have Ujjwal, we have Shane, we have Dan, and also coming up on stage right now, we have Michael. Michael is a distinguished engineer at Shape Security, which is part of F5, and he's been working on TC39 for a long time now. So I'll be asking the questions today. And so I think we've heard a lot about how the committee works. I hope everyone has the link to the Slido, because that's where I'll be sourcing questions from. So I've got that up here. And I can see you're already voting on these questions, which is good. I guess, first of all, just start off so you can lead in. Which proposals that are currently active in committee are you most excited about?
Well, aside from signals, I'm very excited about the pattern matching proposal. Pattern matching will bring the ability of JavaScript to destructure data structures, and it's a common feature in functional programming that just makes a lot of normal, everyday data structure manipulation cleaner and simpler.
Yeah, I'd say I'm very excited about the temporal proposal. This is bringing a new datetime API into the ECMAScript ecosystem. I've worked extensively as a champion on this proposal to make it very install-friendly, ITN-friendly, and I think it's really going to solve a huge gap that we currently have in ECMAScript by bringing a really good, solid datetime handling library.
Yeah, I'm personally very excited about message format. It's a new, relatively effort in that it has only been, 5 years in the making? No, but more seriously, it is in many ways the final boss of internationalization proposals. We've spent many years building the building blocks, and it's a full-blown internationalization system, and I'm very happy that we're standardizing it.
For me, if I'm allowed to say my own proposals, then it would be iterator helpers, a bunch of methods added to iterator.prototype. But if I don't, I would say it's probably base64 encoding and decoding. Very excited about that.
Feel free to whoop and cheer when you hear your favorite proposals. I cannot guarantee it will help them advance, but it cannot hurt.
You can also boo if you hear a proposal that you don't like.
We do like feedback, yes. All right, so just going to the crowdsourced questions. So, Shane, I think this might be going to you, or at least, which is that people are asking, temporal, people have waited for this for a long time. It's been stuck at stage 3 for years and years, and it's still not standardized. Isn't it about time?
Yeah, I'm really excited to see temporal land, as I'm sure many of you are as well. There's been a lot of progress actually just in the last several months. As the champions group, we've gotten feedback from browsers that the requirements that we as the champions gave in the proposal that reached stage 3 were just were very difficult for them to implement. So what we just did just this last week was put forward some changes to the temporal proposal to simplify the API. We simplified it by about 20%. We still have just about all the functionality that we had before, but we made some changes that make it much easier for browsers to implement. I know that Jason in the audience has also been very active in this effort, as well as getting some implementations in Rust and C++. I talked earlier about how IC4X is a really good polyfill for Intel proposals. We also are working on one that will work for temporal as well. This will allow browsers to more easily link a pre-existing native library into the browsers that we can also maybe even use as a polyfill as well. So once all these pieces are put together, I think that you're going to start seeing this shipping, because we're definitely very actively working on how can we make it more feasible for browsers to land. So that's the status that we're in at stage 3.
Great. Anything more to add on temporal?
Well, I think one of the important things when it comes to temporal is to just think about the kind of progress we had made. I mean, temporal started with a very simple but powerful idea of fixing date I think we've gone well beyond that, where we are doing some things that are truly unique in that we had to go back and fix the timestamp format. Among other things, I think the fact that temporal allows you to use any non-Gregorian calendar, most of the CLDR-supported calendars, I think that's pretty powerful, and it's taking a while because it's one of the most complex things we've done in a long time.
Yeah, I think in lines of spec text, temporal is similar in size to all of ES6. So it's a big deal. Okay, thank you. All right, so on to spicy questions. What features or designs does TC39 regret? Which I guess we're asking individually because these are individual opinions. Who would like to go first? Michael?
Well, I can start with the easy answer there, which is that the committee has actually been recently reaching agreement a number of times on some API design design decisions that we've been consistent about in the past, but are now breaking with. In particular, we don't want some implicit conversions to be happening when you pass in values of unexpected types into built-in APIs. So yeah, we've now started a document on our normative conventions, which you can look at. Again, all of our work is in the open, so you can go look at that on our GitHub. And yeah, we're starting to make a break from those patterns that were problematic, that we were following only for consistency purposes, but really were hurting the community more than helping.
I agree. I think all of the type coercion stuff is useful for a certain scale of applications, but for most practical JavaScript code bases, it just gets very confusing. I think the way we're designing APIs these days makes it sort of cleaner and easier to reason about.
One thing that continues to annoy me is how the date.parse is just a complete, it's completely seems random how it works in different browsers. It's not really a very consistent way. I think that temporal is going to move us very much in the right direction here, but yeah, the fact that basically date.parse in every browser works completely differently is definitely a pain point that I wish we could clean up.
So aside from the type coercions, for example, any JavaScript value like undefined becoming nan when you try to use it in arithmetic rather than throwing an exception, I would say one thing I don't like so much was added in ES6, which was symbol species. Many of the array methods were retrofitted with this capability to produce other sorts of types that are not arrays in a way that's very complicated to implement. And I think one of the things that we've decided more recently is that new features going forward won't have symbol species. So we're able to reverse these decisions only partially because we can only do so with respect to new features usually due to our need to maintain compatibility with the web, which we call web compatibility. We can break some things sometimes as long as the web, whatever that means, doesn't depend on it too much. But usually that means just keeping existing things the same.
I have one more. Well, I have many more,
Please.
but I have one more I do really want to mention, which is another one that we've actually recently kind of come to consensus on within committee, which is the default iterability of strings. This causes so many problems, and really was a bad idea from the get-go. As Shane saw with Segmentor, there's many different ways you could split up strings and iterate over parts of it, and we just chose one, code points, as the default, and oftentimes that's not what you want. So we really wish we could undo that one.
So we've heard there is still some hope so long as we don't break the web. That's the slogan. All right. Next up. Well, this is a related topic. Since JavaScript has to stay backwards compatible, is there a chance of a new web language being created from the standards instead of fixing JavaScript?
I don't think that will happen anytime soon. You can't never say never, but there was this hope that Dart would become that future web language, and before that, the VB script supported on the web in Internet Explorer, even though it was dominant at the time, it did not catch on. I think JavaScript is, I think it's a good programming language, or definitely at least good enough. So for another language to catch on, it would have to solve some problem that JavaScript doesn't solve well enough. So it's hard for me to see why that would happen.
One thing I'll add there is, we have WebAssembly, as I was just showing, which basically allows any programming language to be deployed on the web. So I think that this is an approach that a lot of the engines have sort of settled on as like how we can get more languages to be able to be deployed here. In terms of like the native scripting language, I think JavaScript has really shown over the last couple decades that it's a really solid language that it has its flaws, but like it gets the job done. And I think that WebAssembly is sort of the alternative that allows you to basically deploy anything you want on the web platform.
I think that this possibility is very remote and getting more every day. I think JavaScript developers have more or less accepted the fact that despite writing JavaScript, the JavaScript they run is maybe not the JavaScript they're writing. And I think this makes us, not care as much about replacing JavaScript. We can always write on top of it, and it's a solid language for the web, and the ecosystem benefits are just so strong that why would you switch to something from scratch?
All right. Thank you.
I want to mention that this wasn't inevitable that JavaScript remain such a strong language. It's the combination of DC39 beginning to advance again with ES6 and later editions, as well as TypeScript, which make JavaScript a vibrant enough language that the sort of competitors in this space, like CoffeeScript, have somewhat fallen away over time. And so we have to keep up progress in order to maintain the relevance of JavaScript. Also, when Ujjwal talks about ecosystem, I think there's just a lot of benefits to many people using the same programming language. There's a lot of cost to introducing another language.
Thank you. So, Shane, I think you've been doing a good selling job in your talk, because we've got a specific question already of, should I use ICU4X to do my React application translations?
That's a good question. So I'll take a step back first and say that in the TC39 TG2, which is the standards body that we have, we try to attract stakeholders from many different platforms, and we've had some people from React as well as many other web frameworks join our calls. I'll also use this as an opportunity to extend the invitation. One type of stakeholder that we don't have enough of in our TG2 conversations are actual users, like all of you. So this is an open invitation if you want to get more involved. All you have to do is go to the ECMA402 GitHub page, and there's instructions on how you can personally get more involved here. Working with the different web frameworks, has definitely been a focus for our work in ECMA402. Given that ICU4X targets on building a compatible API with ECMA402, that does mean that it's a very natural choice. I know that there's also other approaches, JavaScript-only approaches that could work. But definitely ICU4X is a very viable option, especially if you need to do some of the things that I was showing on the slides.
If you're interested in translating React app, I'm assuming that means localizing it into various locales. I would suggest you to explore message format instead as well. Message format is a relatively new feature I think it's being worked on right now in ICU4X, but we have a JavaScript polyfill for it ready, and we are working on different popular translation libraries like the one that you might be using at the moment to add support for it. But it's a higher level of abstraction that would allow you to have this format and the underlying tool might be ICU4X or some JavaScript library.
One other thing I'll just add there is if you are looking at using ICU4X like in your projects or at your company, like, you know, we're very open and hopefully friendly. Like, just please contact anyone from the ICU4X team, and you know, we always love to learn more about how people are using this library in the wild.
I also wanted to mention that ICU4X is maybe the best for advanced cases, but for a lot of well-established APIs, we have the Intel library that's built into JavaScript that you can use without installing anything, without you know, with an even smaller download size. So if that meets your needs, then it's probably best to start with the platform solution and then expand to additional libraries where needed. Also, consider ecosystem libraries like Format.js, which build off of these Intel libraries and provide a higher level interface.
Thank you. So we're back to a spicy question. Do you have to manage pressure from commercial interests, e.g. Google V8, Apple with JSC, and how do you do that in the standards process? Who would like to take that one?
I can say a little bit, I guess, which is that, you know, I sort of, you know, like, I work at this company called Google, but I'm also not on the V8 team. I'm on the internationalization team. So, like, you know, a lot of the times, like, you know, the things that I'm trying to get out of proposals, making them better for global multilingual users, are not necessarily the things, like, you know, like even at V8, that, you know, V8 is looking for things that are small and efficient and things like that. So there's definitely a lot of, you know, trade-offs that go into any of these proposals. I think we see with ECMAScript, or sorry, with temporal in ECMAScript, with ECMAScript temporal, we've seen how, like, you know, the ideal way that we would like to do datetime formatting ended up being sort of challenging for browsers to implement, and I think that sort of drove, you know, a lot of these changes that we just saw this week. But I do think that all the browsers are very cooperative with the body, are very active in TC39. And, you know, understand that, you know, there's not a single stakeholder who really gets to make these decisions.
I'll just add that, you know, it is an inherently difficult problem because everybody has different motivation, but our process has been developed over, you know, the course of many years to, you know, tackle this specific problem, and, you know, it allows us to iteratively approach, you know, a solution that is agreeable to everyone involved.
Right. I'd also add our process is very conservative. In particular, because we need consensus to add things to JavaScript, as Ujjwal explained, and because changes need to be web compatible, there's quite a high bar to changing JavaScript. And this means that the only way that you can work on a committee is to be a rigorous technical professional. So this is kind of common across standards in general, that although people come from different organizations, it's not like you forget who they work for, but you try to leave it aside and try to focus on the common technical project. And I think we do a pretty good job of that in TC39.
Yeah, the benefits of consensus. You cannot whip the vote when there is no vote. Yeah. All right. Next up. Why do you keep calling JavaScript ECMAScript? What's the deal with that?
There may or may not be a trademark for JavaScript. I mean, Oracle claims they have a trademark on it, and we'll see. For now, ECMA has the trademark on ECMAScript. So as long as JavaScript has been standardized, it was always the ECMAScript standard. And I think it's a fair reminder that ECMA has a constructive role in JavaScript.
Thank you, Dan. So another Shane-inspired question. What suggestions do you have as to what kind of things I should write as a polyfill with WebAssembly and use them in JS?
Yeah, I promise I didn't plan any questions. I really didn't. But yeah, I think that's some of these heavier library features that we're adding, like interval segmenter, was sort of like the perfect example for where WebAssembly makes a lot of sense, right? Because it's very data heavy of an algorithm to implement. I think that some of these other libraries that we're adding, maybe perhaps duration formats is another one we're adding. I think message format is one that could be compelling. To have implemented in IC4X. I think that there's also some counterexamples. Like I think probably signals probably makes sense to have a JavaScript direct implementation. I wouldn't say that there's a one-size-fits-all solution here. The purpose of my presentation was to show that look, this is a thing that I think that people haven't done enough on the web platform, which is really try to integrate ECMAScript and WebAssembly together, because they really can work together in harmony. And I think that's something that people haven't done enough of. And I'm just sort of showing an example for how this actually can get the job done when it's the right tool for the job.
Actually, with the WebAssembly GC support, I think WebAssembly would be a great way to implement signals, and would encourage anyone who wants to contribute a signal polyfill in WebAssembly. I want to emphasize part of what Shane said. ICU4X is looking for an implementation of message format. If you want to learn Rust and WebAssembly, this would be a great project to get started on. There are many strong they're very good at mentoring people and supporting efforts like this.
Okay, thank you. All right, a question around task groups. What determines when and what task groups are created? For example, why was a task group created for source maps?
So I worked on creating the source maps task group with John Cooperman here.
John, please stand up and wave.
Kind of co-convening the group. And all it takes is the committee TC39 to agree, yes, we want to start a task group, and then there's the task group. And for source maps, we decided to create a separate group because we thought that it is just a separate thread of investigation. So TG4 for source maps works a little bit differently from TG2 in that we're doing our development completely separately, and then we're working on bringing the final result to TC39 plenary. TG2, which I worked on setting up some years ago before Shane took over, is, with this model of working on something and then proposing it to TC39. I think both models work well. And ultimately, task groups can allow TC39 to scale its behavior to more projects than would be capable of doing if everything had to happen in plenary.
I heard that JavaScript developers kept getting lost, so we thought we'll give them a map to find their source. Moving on.
Yeah, that's why we convened TG4, yes. But by the way, it's also possible and quite common that we work in what you could consider ad hoc groups. They're just people who get together and talk about things. And most of the meetings on that calendar were ad hoc meetings rather than task groups. Task groups are more appropriate if you have sort of a long-standing program of work that you're going to continue among a set of people.
So a question about our process in general. What is the average time it takes for a proposal to pass all the stages?
I think there's no good answer to that. I think, they're all over the place. It really depends on the proposal and the kind of, the cast that it brings together to sort of, be focused on. There's certain proposals that have been small to medium size and have really blazed through. There's many reasons for that. It could be that it's quite straightforward what the problem space is and what the solution needs to be. And other times there's proposals like temporal or decorators, which are quite complex problem spaces, and it's difficult for us to get clarity on how exactly it should be defined. Maybe there's not a whole lot of agreement among the committee, and then we have to work on building that kind of consensus from the ground up. So I think it really depends on the proposal, and there's no generalized answer that I can give.
Just to give an idea, though, so that we can work with like concrete numbers. Yeah, the smallest possible proposals with like a very direct, very obvious solution space is probably 6 months at the fastest. Whereas the longest proposals we work on, I mean, I've only been with committee 10 years, so I'm not sure. I'm not sure how long they could possibly last, but maybe that's like 7 years or so. But your medium-sized proposal, you're probably looking at like 2 to 3 years through the whole process from beginning to end.
Yeah, and the reason it's so hard to characterize the answer is because it's not like you submit a proposal and then a timer starts and then it becomes a standard. It all depends on, first, whether it's actually a good idea that we can have consensus on. So imagining it as a timer implies that it will eventually happen, but maybe we shouldn't do it. Or maybe the people in the group who started the proposal are busy with other things and they don't bring it back to committee until someone else comes and picks it up or until they find time again. There are all sorts of reasons for things taking different amounts of time. For example, we're considering decimal in TC39 now, and that was under consideration at the beginning of this century. It was considered for ES4 or even earlier than that, and we're still considering it. So there's no time limit. We're not saying no to decimal just because it's been taking a while, but it also wasn't even under continuous development.
All right, and on that subject of things that may not happen, we have a question. What happens when some browsers decide not to implement a feature?
Well, usually before a feature would even get to stage 3, which is the kind of stage at which you start expecting them to implement it, they have a lot of different areas, a lot of different venues to voice their concerns. I think the fact that we work very closely with our colleagues in different browser teams makes it kind of impossible. I mean, hypothetically it's possible, but we work very closely with them to address their concerns. And even within stage 3, we reserve this, like we were talking about what happened with temporal, with us simplifying the proposal a bit. We reserve the ability to improve on proposals during stage 3 as well, listening to their concerns. So I think there's, no kind of, the process avoids this from ever happening.
Right. I think we have a good flow these days where if browsers are not interested in eventually implementing it, then they won't agree to stage 3. That is the ideal path and way of working together, and I think we've been delivering on that recently. One of the things that we started doing more recently is looking through our past proposals that are at stage 3 or 2 or 1 and checking in on where they are. There's maybe one stage 3 proposal that hasn't yet gotten much interest from browsers, and so we'll eventually be reconsidering, should it still be at stage 3? Is that an accurate way to consider its status? But we take these decisions slowly and carefully, and it would be an exceptional case.
All right, so I think we're nearly ready to wrap up. Maybe one last question. I think this is provoked by your talk, Dan. And the question is the signal reactive model always more efficient than the virtual DOM? Or are there trade-offs?
There may be trade-offs. In particular, when running the code for the first time, you have to do this auto-tracking and construct the signal graph. So traditionally, people have said, that takes too long, and virtual DOM should have a faster initial render. However, these days, people are thinking more in terms of SSR, where you have, it initially ships HTML, then it hydrates, or maybe it's presumability, but I think that's incremental hydration. So ultimately, the initial render should be handled by something like that. and hydration techniques have been developed for both signal-based systems and VDOM-based systems. So in general, there is cost to computed nodes and their caching, and sometimes it does make sense to recompute more things. This trade-off exists in React as well, with the React compiler now making certain decisions about which things to memoize and which things to not memoize. And I think it's subtle, but I still am optimistic that signal-based rendering is a good way to go about things.
All right, thank you, Dan. So yeah, let's wrap it up. Yeah, and I'll say thank you to our panelists here, Dan, Shane, Ujjwal, and Michael.